So this is the specialist paper 2020, paper 2, Tech Active. Question 13. The data records show that the speeds of cars at a particular location on the highway are normally distributed with a mean of 98.7, standard deviation 4.1. The speed limit in this location is 100. The police office plans to record speeds of 20 randomly selected cars in this location. Determine the expected number of cars in the sample that will be travelling within plus 1 or minus 1 kilometres per hour of the population mean. Okay, so a few things we're going with. We know that mu is 98.7. My standard deviation is 4.1. I'm looking for 1 kilometre either way. So 97.7 to 99.7 is where I'm looking for my probability, isn't it? Between those and that. Now it's normal distributed, so I'm going to go to distribution, normal, NCD. My lower is 97.7. My upper is 99.7. My standard deviation is 4.1, and that's 98.7's there. And I get the probability of 0.193. So my expected number of cars there out of my 20 will be 0.193 times 20. So I'm just going to go back to my run map mode. Let me delete all that. So I'm going to go 0.193 times 20. It's going to give me an expected, that's around 3.85. So I expect 4 cars will be travelling in between 1 and 1 kilometre from the expected, from the population mean. Determine the probability that the mean speed of this sample will not exceed 100. Now we're looking of this sample. So while my mean will stay at 98.7, my standard deviation will be 4.1 over square root of 20. I'm looking at the probability that X is bigger than 100. So I'm going to go into my stats mode, distribution, normal, NCD, bigger than 100. So 100 is my lower, upper 9999. My standard deviation will be 4.1 divided by the square root of 20, means the same there, and I get the probability is 0.078. Going to 2 decimal places, probability is 0.08. Giving our answer in 2 decimal places. Now it's saying there is a 5% probability that the mean speed of the sample will exceed K. A 5% probability. So from our normal distribution, here's our 98.7, here's K, and this is 0.05. That's my 5%. So I need to work out what that K value is. So I'm going to go distribution, normal, inverse. This is a left tail. Oh, sorry, no, it's not. I've got my left and right mixed up, haven't I? Looking at my diagram, it's a right tail. So it's a right tail. It's 0.05 because it's 5%. The standard deviation is the 4.1 divided by the square root of 20. We do that through and we get K equals 100.2. I would make track here that what I did on my calculation, I went distribution, normal, inverse n, and I'd list what I put into my calculator as some working for where we're going. Okay? And that is the end of that question.